Hello, this is question 2 on June 2015 Mechanics 3 paper from AQA. It's an old specification question, but it's quite interesting because you have to find the trajectory. A projectile is launched from a point O on the top of a cliff with initial velocity u at an angle of elevation alpha and moves in a vertical plane. During the motion, the position vector of the projectile is x, y, meters, I and j are horizontal and vertical unit vectors respectively. So that during the motion, the equation of the trajectory of the projectile is given by this. So if we use this diagram, just considering that this u, I'm going to write u, and this angle is alpha, so we don't know these numbers. Let me write here that this is u and this is alpha. So they are giving us the position vector. So for any point, if I have this point here, the position vector is going to have coordinates x and y. Yeah, so they are just giving us those coordinates. So this is x and the vertical one is y. And we need to find a y in terms of x. What we are going to do is to work with the vertical motion and the horizontal motion separately and try to connect them. So if I think of the, I don't know if I have space, yeah. So for the horizontal motion, we know it's constant velocity. So we know the horizontal distance, which is called x in this question, is going to be the velocity times the time, the horizontal velocity. And the horizontal component of the velocity, remember, is going to be this one. It's going to be constant all the way, and it's u cos alpha, because it's adjacent to the angle. Yeah. So that initial velocity is u cos alpha, is constant, and then times by the time. If we look at the vertical motion, we have something moving freely under gravity. So really we have something with constant acceleration, which is the gravity, and we can write a Subat equation that connects our variables. So what x is the displacement is going to be this y, yeah, the vertical displacement. So it's going to be y. The initial velocity is the vertical component of the velocity, so we can say that this is u sine. So u sine alpha, u sine alpha. I'm considering this positive. Velocity, we don't need it. Acceleration is going to be minus the gravity because we say it's positive upwards. And this time, so let me write a Subat equation with a v, which is this one. The time for both of them is going to be the same. Yeah, so this time here and this time here is going to be the same because the particle is going to be at one particular position for a time. So if we substitute here, we have that y is u sine alpha t minus, because the gravity is negative, 4.9, I'm going just to divide by 2, t squared. So what we really have is one equation here and another equation here where I have all my parameters and I have a t that I don't have in my equation. Yeah, it's like having parametric equations, and what I'm going to do is to eliminate t. So we say that x is u cos alpha t, and y was u sine alpha t minus 4.9 t squared. And I'm going to eliminate alpha and t, sorry. So I can make t the subject in the first one, so I can make t is x divided by u cos alpha. I'm substituting the other one, yeah? Or here, I'm going to substitute in the other one. So I have y is u sine alpha. Instead of t, I'm going to write this. Minus 4.9 t squared. So x divided by u cos alpha squared. So that means that u, we can, y, this is cancelled, sine divided by cos is tan, is going to be x tan alpha, and let's going to see how they write the second part, just like we have, yeah? So it's just minus 4.9, and I square this, so x squared in the numerator divided by u squared cos squared alpha. And that's my trajectory. This is the formula that I need to find, yeah? So that's the first part. Then for part B, it says when u is 21, so we are back to what we had here. So this u is 21 and this alpha was 55. I don't know where I deleted. Okay, it's here. So the angle is 55, and then the projectile hits a small point here. It hits this point, and the distance, vertical distance is s, and horizontal distance is s. So we need to find the value of s. We have an equation that relates the x and y for each point. So we just need to substitute the y by minus x. This is the origin, so this s down is going to be minus s, and the x is going to be s. Yeah, so we are just going to substitute in our trajectory equation the x by s and the y by minus s. If we substitute here, we have minus s is s tan 55 minus 4.9 s squared divided by u squared, which is 21 cos square 55. Yeah, we could cancel s everywhere, but remember that when we cancel a variable, that could be 0. Yeah, so one of the possible answers would be s0, and that's because that would be this point here. Yeah, because the x and the y are the same here, are 0, 0, both of them, and the next time that they are equal to each other is this one. Yeah. So the other option is that s, so I have this s here, is going to be I'm going to put everything on there. So let me do in steps. So I have 4.9 divided by 21 squared cos square 55 times s is going to be 1 plus tan 55. Yeah, and from here it's just easier. So I'm going to do with the calculator this number here divided by all this, and I get that s is 71.895 meters. Do we have to round to something in particular? No, they don't say, so I'm going to round to 3 significant figures. So s is 71.9 meters to 3 significant figures. That's B. And then C, well, no, that's not B, that's BI. So the first part. And then the second part says, find the acute angle between the velocity of the projectile and the horizontal just before the projectile hits B. So we are talking about the velocity here. So the velocity is going to have an angle. Yeah. And this is the angle that they are asking us. This angle is going to call it beta, for example. We know the horizontal component because it's going to be constant all the way. So the horizontal component is the same that here is u cos alpha. So the horizontal component of the velocity, the second part, so the horizontal component is going to be u cos alpha, constant all the way, so 25 cos 55 degrees. So this is, I don't have the number, but I can tell you. This is 12.045. Yeah, and the vertical component of the velocity, so this one here, I'm going to use subat to find it. So I'm going to write subat again, and I can find that final velocity. So if I consider positive up, s is going to be this one here, yeah, but negative, because my particle now is here, is minus 71 point something meters below it started. So this is going to be minus 71.9. Initial velocity is u sine, so 21 times sine 55. Final velocity is what I need. Acceleration is minus 9.8. I'm considering, I say this one positive, and the time we don't need. So we can use a Subat equation without time. V squared is U squared plus 2AS. V squared is what I need. U squared is 21 sine 55 squared. This minus with this minus becomes plus, so plus 2, I don't have space, 2 times 71.9 times 9.8, and I get two values of V. I'm going to pick the negative one because I consider positive up, and here my vertical velocity is down, but it really doesn't matter because the numbers are going to be squared, but just to be more precise. So this V is minus 41.292 meters per second. So what I have at B, so if this is B, I have a horizontal component of the velocity that it was 12.05, and I have a vertical one that is 41.3, let's say, 0.3. So I need, this is my velocity, at B, my velocity, and I need this angle. This is my beta. So I can use just trigonometry. Tan beta is the opposite, 41.3, divided by adjacent, this one, just looking at this triangle, yeah? So tan beta is 41.3 divided by 12.05. I divide that, I do tan minus 1, and I get that beta is 73.73 degrees. And we have to give the answer to the nearest degree, I think. Nearest degree, yeah? So this is going to be 74 degrees to the nearest degree. And that's it. That's all with this question.